Let's start this second part of today's session. My name is David Pelta. I am from the Department of Computer Science and Artificial Intelligence from the University of Granada here in Spain as Juan. I belong to the research group on models of decision and optimization. And I will talk on generative AI, some basic aspects and some point for discussion on what is available up to now. I don't know what will happen tomorrow, so this is what is available up to now, okay? I will describe some basic concepts around generative AI and artificial intelligence too. I will describe some applications. I will try to write some discussion about the impacts and some conclusions about this topic. Okay, what we mean about generative AI? Essentially, generative AI is AI, artificial intelligence, with the ability to create new and original content in some sense from the data with which it has been trained. The system is able to learn patterns and structures from large data sets, and once trained, it can generate new data that follows the same statistical distribution as the training data. Okay? But what we mean when we say that an artificial intelligence is able to create something, okay? This is quite complex to formalize because, in fact, there is still no consensus definition about what is intelligence. So it's quite hard to define what is artificial intelligence. Juan also shows a couple of, let's say, official definitions, but it's a very polarized concept. There is some interdisciplinarity in the field, different contents and application. There are a lot of misleading news and hype around AI. And in this slide that belongs to a colleague called Dagmar Monet, she put these two sentences that the concept of artificial intelligence is aspirational. It's a moving target based on those capabilities that human possesses, but with machines do not, okay? And it shifts with technological advances and our expectation from computers. And in this sense, it's pretty hard to determine what is or is not artificial intelligence, okay? And to illustrate this stuff, we can think in something like this, in a scientific calculator. Nowadays, no one will put the intelligent label on this hardware. However, maybe 15 years ago, or 70 years ago, this will be called a magic device, okay? So let's see some basic concepts around this. Please remember that when we talk about artificial intelligence, essentially we are talking about software, computer programs, okay? So around this generative AI, there are some basic concepts, like, for example, foundation models. And what is a foundation model? Well, the first thing to say is that the term was popularized in 2021 by researchers at the Stanford Institute for Human-Centered Artificial Intelligence. And they are defined as models trained on broad data that can be adapted to a wide range of downstream tasks. They are capable of a range of possible tasks and applications, such as text, image, video, audio, or whatever generation and manipulation. And they can be standalone systems, or they can be used as a base for many other applications. These foundation models are built using established machine learning techniques like deep neural networks or other techniques like transfer learning and self-supervised learning. Besides this foundation model idea, we have the concept of large language models, LLMs. And a large language model is a type of machine learning model designed for natural language processing tasks. Okay, so LLM is a type of foundation model oriented to natural language processing tasks. A typical example of an LLM is what is called GPT, which is the acronym for Generative Pre-trained Transformer. It's an LLM created by the company OpenAI, okay, the owner of ChatGPT. And in very basic terms, LLMs are linguistic prediction models that are built on the so-called transformer architecture. And the idea is that they can analyze natural language queries, known as prompts, and predict the best possible response based on some internally calculated probabilities. So we have these foundation models. A type of foundation model is the large language models, and these large language models are based on the transformer architecture. That's the main idea. And what is a transformer? Well, essentially a transformer is a type of neural network architecture that is specifically designed to process data streams. And the architecture is quite complex. We can have a month or so for providing a detailed explanation, but essentially they have three main blocks. One is the so-called encoder that converts the input data into a format that can be processed by the computer and that in some way stores the context information. The encoder essentially represents or transforms a word or a token as a list of numbers, okay? And this list of numbers, which is called a vector or an embedding, is the only thing that the machine can process. Words are represented as list of numbers, and all the process is being done on list of numbers, on vectors, okay? Well, the other feature of the transformer is the so-called decoder that departs from the encoder information and generates the next most likely element for a given sequence of information, for a given text, okay? The next most likely element could be a word, a token, or a summary, or a rephrasing, or whatever, okay? And the last important feature of the transformer is what is called the attention mechanism that allows to focus on specific parts of the data, of the sequence data, and this is used to improve the performance of the model, okay? Well, this is more or less the idea, but what we mean by large when we talk about large language models? Well, by large, we refer to the number of parameters that the model has, okay? If you recall Juan's talk when he displayed these neural networks, we have these small arcs between the circle, between the neurons. So every parameter is essentially a value attached to each of these lines. So these large language models, for example, GPT-3, has 175 billions of parameters, okay? Billions of parameters. This is a huge number. So these models presents a lot of challenges from a computational type of point of view in terms of how we can storage this model, how can we train, how can we manipulate the model, okay? These models are really high, really, really high. And what we can do with these foundation models of large language models? Well, Well, essentially, we can construct applications, generative AI applications. And these applications have many different flavors. For example, if these applications are oriented to text manipulation, we can find applications regarding with marketing content or assistance for writing emails, for creative writing, for translation, for legal and technical text, for writing or providing news articles and summaries. If we talk about videos, we can find generative AI applications oriented to automated video generations or video editions or virtual reality or augmented reality. If we talk about coding, programming computers, we can find applications about code generation or code complexity, refactoring the code or optimizing the code, applications that helps in the bug detection and fixing, also on code formatting. We can find also applications for music in terms of composition, sound effect design, virtual instruments, or so on. Of course, in terms of speech, we have text-to-speech applications, virtual assistants, voice cloning, artificial voices, and so on, and so on, and so on. Okay? But we need to have a clear distinction between an application and a model. Okay? One thing is the application, and one thing is a model. And the range of models we have is huge. Okay? In this place, Hugging Face, you can see, or you can find a lot of models, or foundation models, or large language models. And these models are able to perform many tasks. And some examples you can be seen here, okay? You can have applications, models, better say, that transform text to image, or images to text, image to video, image to three-dimensional schemes, applications for performing visual question answering, for image classification, for image segmentation. In the field of natural language processing, we have applications for feature extraction, for summarization, for text generation, for analyzing sentence similarity. In terms of audio, for example, for transforming text to speech or text to audio, or for automatic speech recognition, audio classification, voice detection, and so on, and so on, and so on. You can see here in this page applications constructed over this kind of models. Okay? So, the other interesting concept in this generative AI is the concept of fine-tuning. And the idea here is that fine-tuning allows users to adapt pre-trained large language models or foundational models to more specialized tasks. Okay? So by fine-tuning a model on a small data set of a task-specific data, you can improve the performance of the model on that task while preserving its general language knowledge. You can see here an example where you have a pre-trained model, perhaps from data available in internet. We can, using specific private knowledge base, run a supervised fine-tuning process to obtain a fine-tuned large language model. And what is the impact of this? If you see this scheme here, we have the basic model here, and we have a query, a prompt here, okay? And using this prompt on this foundation model or LLM, we can obtain an output that says allergy, for example. However, if we have this base model, we can fine-tune it with some allergy data, and then when we ask this fine-tuned model the same query, we can obtain a better response. Okay, that's the idea of the fine-tuning. And there are many ways to do fine-tuning. Some of them are, let's say, quite easy, but many of them are quite time-consuming in terms of human experts. Okay, it's not trivial. It can be done, but it's not trivial. Okay, so what kind of applications we can construct using these LLMs? Maybe you are aware of many of these. Chatbots and voice assistants. Okay, this is a typical application where the main difference between these LLM-based applications and previous one is the ability to interact using natural language in a more informal way. Other applications are the content creation and text generation, okay, for doing good things and bad things. Language translation. There are some fantastic applications in this field, which are very useful for those of us that we don't have English as the first language. So, for example, we can use it for rephrasing some text and avoid it, and in this way try to avoid some plagiarism detection software. There are some tools for content summary and conversion. Of course, there are some applications on data analysis and also on codification. As long as I'm talking about this seems to be a fantastic work, okay? Some marvelous applications that can help us in many, many tasks. But there are some basic considerations for the use of generative AI on any of the flavors it comes. The first one, the responses, the outputs of the systems may be incorrect or outdated, okay? Because unless something is done in the fine-tuning process, the information is frozen in the pre-trained model. You should be aware of this. Of course, these systems can reproduce biases present in the training data, or they can generate inappropriate content. So, for example, it's very important to not enter sensitive, confidential, or personal information. Of course, they can be used to generate harmful, offensive, or illegal content. And if we go back a bit on data privacy, one should be aware, for example, where does my data go after I use this model? Is my data stored? And if so, how securely it is? Is my data shared with any third parties? How is my data used to train or improve these models? What are the privacy implications of interacting with these models? Okay? It should be very clear that there is no true understanding or human judgment. The output of the systems is based on statistical patterns and should not be considered as an expert advisor. Although sometimes the perception is quite different, okay? When you interact with ChatGPT or Gemini or Copilot, they can provide great things if you know what you are talking about. But there is no way to ensure that the outputs are correct. In some sense, many times, they are, let's say, like a bad politician. They can provide a nonsense answer to every question that looks as a reasonable one, okay? Of course, we have the idea of hallucinations, that they provide text that is syntactically correct but has no sense, or there are some factual errors, we have to be aware of the cost of the errors, okay? We already talked about data privacy. We have the ethics stuff. We also have the copyright stuff. Sometimes it's not clear where the training data came from. Okay, this is a problem in these large systems. Nowadays, there are people talking about the model collapses because the good information, the information generated by humans with all the biases and all of this stuff is reaching an end. So what happens if we train this model with generative AI data? In fact, the performance degrades notably. So we need to think about the impacts of this stuff, okay? And regarding the impacts, you can see the newspapers or whatever, but you also can check some papers from academia or other things. So we have impacts in terms of social or environmental impacts. We have junk science because there are AI fabricated papers that floods Google Scholar. There are also AI generated images threaten science because there are fake images published in research articles. Even the International Monetary Fund talks about that AI will transform the global economy. And they say, okay, let's make sure it benefits humanity, but we don't know humanity in which side of the world, okay? So in any case, they say that AI will affect almost 40% of jobs, okay? But what type of AI? What type of jobs? Well, there are a lot of information about that around. And of course, we should not forget about this. This is very important. We have here the years, we have here money in billions of dollars. So here, Microsoft, Alphabet, Meta, Amazon, and Oracle, they spend around $200 billion into AI infrastructure in the past years. And they plan to invest more in this 2025. Even just Microsoft alone projected to spend $80 billion on data centers alone, okay? We have this situation. Of course, you are aware about this one, this project AI Stargate, where the US government and some companies and some banks plan to develop a 5-year project investing $500 billion in these projects. And of course, you are also aware what happened the last week with this tool, DeepSeek, from a Chinese startup that says that they can do the same as ChatGPT does, but using few resources and much more less money than ChatGPT. Okay, so we don't know what will happen the next week. Some people is talking about the end of ChatGPT, but what happened with Copilot, with Gemini, what happened with the applications based on them. Okay, so the current situation with all of this generative AI and the hype about AI is something like this. Okay, maybe you feel identified with this guy asking for help in a sort of tsunami of information about this. And this is a very complex situation, and what we can do about this? What we can do about this? And the answer is far from trivial. Okay, the answer is far from trivial, and maybe the first things to do is to avoid this thing called FOMO, the fear of missing out. And FOMO is caused by a feeling of anxiety when one has a belief that they are missing out on an exciting opportunity. This is more or less what we are experimenting from the first appearance of generative AI, like ChatGPT and so on. And we should be aware that it's impossible to keep up with the pace of news and developments associated with artificial intelligence, because the constant hype is damaging the field. And we have, let's say, more classic artificial intelligence based on machine learning with the tools that Juan commented before, that they are being used for solving relevant problems, okay? Nowadays, we have impressive applications of generative AI, mostly for dealing with text-related tasks. So my main advice is to try to understand the problem you want to solve. This is the first thing we need to do in academia, okay? We need to understand the problem we want to solve, and then we will search for the right tool. Let me put you an example of some stuff that I don't know exactly for what it works. I don't know if you use this tool, Notebook LM. It's a Google tool where you can upload some documents, okay? And the system is able to generate a podcast between two journalists, a man and a woman, okay? And if you listen to the podcast, it sounds incredible. It sounds incredible, okay? But you don't have any certainty about how they select the content to explain. You don't know if they are telling the important parts of the paper or not. And nowadays, you have another option. You can interact with this virtual journalist. And the question is, which is the usefulness of this? If you cannot ensure that what they are saying is true, or if you cannot trust if what they are saying is true, which is the usefulness of this? Okay? And we are flooded in some sense with a lot of tools that it's not clear what is the usefulness of them. So, this is my last slide, and I wish you to remember that domain knowledge is essential for validating the output of this system. We should not ask these systems like ChatGPT for things that we don't know, because we cannot trust the answer. We cannot trust the answer. So if you know what you are talking about, you can ask for the information, or for example, you can rephrase some text, or ask for some computer code to do something that you know what to do, but you don't know how to do it, that you can ensure that the code provided is correct. Okay, so in this sense, in this scenario, you can use it. Otherwise, you cannot trust the output. Okay, you will ChatGPT if you have a pain in your knee, which could be the problem. Okay, don't use it for this. And we must remember also that AI and algorithm, which is a word that I don't explain here, are tools created and promoted by people. Okay, so artificial intelligence and or algorithms are not guilty of anything. Okay, we cannot make guilty an algorithm of anything. The focus should be put in the people behind artificial intelligence or the algorithm. We must remember that besides science and technology, there are business, money and a fight for power. Okay, so I think I will finish my presentation here. I will be happy to hear your opinions or comments or questions or whatever. Thank you very much.